After rigorous testing, devnet and public testnet merge, Ethereum blockchain is just a couple of weeks away from the mainnet merge. As Ethereum cat herders, we are committed to sharing information via Know Your Client series to increase your options as a node operator to choose the client that suits you the best and is convenient running a node post merge. If you are ready to be an Ethereum node operator, continue watching. Welcome to PEEPanEIP episode 85. I am Pooja Ranjan. With me is an Ethereum client developer Gajinder Singh, and we are going to know more about Ethereum JavaScript client. About the client, currently managed by the Ethereum Foundation, Ethereum JavaScript monorepo is one of the oldest client repo for Ethereum blockchain and has been in active development for execution layer for quite some time now. It has also participated in the merge testing. We will learn more about Ethereum JS in this episode with Gajinder Singh. About the guest, Gajinder has been a contributor to Ethereum JavaScript client development on execution layer. So let me welcome Gajinder Singh.
Hi, Pooja. How are you doing? And hello, everyone. I'm Gajinder, and I'm happy to be here to represent Ethereum JS, which is basically a merge-ready JS execution. And we are quite popular on GitHub. We have 1.9K GitHub stars. Uh, the team is led by Hoger, Johan, Andrew, Gabriel, myself, Scotty, Amir. We are few of the team members, and then there are a lot of contributors who have really contributed into Ethereum JS.
It's nice to have you back again, Gajinder. For
Yep.
people who may have missed, we have recently recorded an episode on client Lodestar, which is a complementary consensus layer client in TypeScript for Ethereum JS. I'm looking forward to hear more and learn about the execution layer client, Ethereum JavaScript.
Yep. So Lodestar also belongs to the JavaScript plan, and Ethereum JS and Lodestar are sort of the same. So the going full stack on the JavaScript TypeScript ecosystem. Uh, yeah, coming to Ethereum JS now, what really Ethereum JS provides is the building blocks for the JS, Ethereum, and Web3 community. So what we have we have the code base, which is really modular. We have tons of libraries, and which are readily used by IDE and test suites like Hardhat, Truffle, Remix, and tons of Web3, NFT, and wallet projects. And as you can look at our npm dependents, and but we are also trying to pave way for a decentralized future using for decentralized future via light clients as well as portal network. And we have basically an SDK called Ultralight for that as well. So as you are all aware, Ethereum's merge is upon us, and in maybe 15 or 16 days, uh, Ethereum mainnet will be merged. And what it really means is that Ethereum will be off the proof of work consensus, and the execution layer, which is basically execution payloads, which is really the blocks that are part of our traditional chain. They will be subsumed into the beacon chain, and that responsibility of minting the blocks, of adding the blocks onto the chain will go to the beacon chain. But the responsibility of executing those blocks and modifying Ethereum EVM state still remains with the execution clients, and they CL clients and execution clients have to work in tandem to achieve this. So to that end, we have a merge ready, fully functional client, which is a bit experimental in nature. And I will go why it's experimental a bit later into the presentation. But we basically have great success on Kiln testnet, which is sort of now deprecated. So you can run us on Sepolia with any of the CL combinations, and hopefully, basically, we will sync to the head. For Go Early as well, you can try us. But yeah, the fun thing about Go Early running us on Goerli will be that, you will have to put a lot of resources as well as patience for us to catch to the head. And the reason for that is, again, we'll go into a later part in the presentation. Mainnet, we are also merge ready for mainnet, though we'll have similar challenges as mainnet is also quite big. And but we are merge capable for mainnet as well. And to come to this point, we have had some uh, fun along the way. And since the point when devnets started, when pithos started, and then we successfully uh, killed uh, with the kill network. And moving forward, we were able to even produce. So kill network was a huge success for us, because uh, even the community members ran Ethereum JS combinations with other CL clients, and some of those combinations also produced blocks with transactions inside them. So we demonstrated that Ethereum JS client is a full stack merge capable client. So since our main audience is developers, so what does it mean for them? Now, the hard fork support in all our libraries, we have the post-merge hard fork support, which really means is that, they can build and test post-merge transactions. And if they want to even go further, they can accurately estimate the gas cost using some of our advanced features. And for the developer suites and test suites, they can provide safe and finalized pointers, which is the main value proposition that uh, proof of stake brings to the Ethereum ecosystem, is that with the latest pointer, you have the finalized as well as safe pointers that you can use to access the state. Earlier you used to have latest and then wait for confirmations for you to basically say that, okay, the block is freezed and now I can release the funds. But now we have these goodies coming from the CL land, and that are also available in Ethereum JS suite, and readily can be used by the test and developer suites using our libraries. And we also uh, basically want to pave the way for in-app and in-browser like clients. And the reason for that is that now the CL clients can also bring onto the table like clients, but they don't really marry it with the execution. And that's where Ethereum JS libraries come into picture. You can marry Ethereum state with those light client headers, and basically can give you the picture of of the contract or the address, or whatever section of the state that you want to be concerned with. And that is really the value proposition of light clients. And all that is possible through a merge capable EVM. uh, so we have our EVM modularized into EVM and VM. Basically, EVM is the main thing that executes the code, and VM is the module that really brings together the blocks and transactions and the states to marry into that EVM that can run the code. So with the merge capable EVM, now you can consume and run post merge blocks. And so precompiles are available to the developers. uh, and when in the future, when the new hard post merge hard forks will come in, obviously those will also get available, because we are through the barrier of the merge. And after that, uh, providing new hard forks and new precompiles will just be a routine task for us. And doing all this merge efforts makes our EVM and VM really battle tested, because what really so a developer who is using a IDE or a test suite based upon Ethereum JS libraries, they would want that, okay, whatever they're developing, it's accurate and it will work on the mainnet uh, in the exact way that that they have developed. So for that, it's important, it's very imperative that we, Ethereum JS, is able to sync and run testnets. And for that reason, we also want to sync and run mainnet. But for that, there are a couple of challenges that we'll have to solve first. And the good thing about our VM is, if VM and EVM, is that you can run in browser, in app. This is sort of work in progress, but we have made good progress that you can basically get finalized and latest pointers to the blockchain. You can source partial state with proofs, right, using the current JSON RPC APIs, and then you can run contract code in app in browser. And this is really useful in IDEs for the DeFi apps, and in the games, and in the contract explorers. And when we are talking about bringing the state data to the EVM, what so there is this portal network that is being developed, which can provide partial state, partial history uh, to the consumers in a way that they can also verify it. Now, this can basically, the use of this is that you can use this to replace your centralized provider. And as we have seen recently, that censorship is a big issue. And uh, so people need tools to move away from a centralized provider, so that they can rely on a decentralized ecosystem. And that's where I think the portal network comes in, and our Ultralight SDK is a gateway for that portal network, to bridge that portal network data uh, into an a compatible EVM or compatible client which can consume it. And for us to become merge capable, we had to introduce new sync mechanisms as with everybody else. And so once we are off the proof of work, the only way a execution client can uh, get new data is through the engine API. So basically, the CL clients will source or create the blocks, will build the blocks and source the blocks, and then those blocks are provided to Ethereum JS using the engine API. But there is one constraint over there, that CL clients and the EL clients have to be in lockstep. For example, you are at head X in the CL client, so you have to be on the corresponding head X dash in the EL client for the new payload for the new block to come and be executed. But what if you are not at X? You are at X minus 5. So to solve that problem, beacon sync is what really solves that problem. And what it really means is that CL clients will tell you where the head is, and then you will go do a reverse backfill. You will to the point where, or to the last state that you had. And if you don't have anything, then all the way to till genesis, or all the way till the state that you have synced using snap sync. So you will backfill to that state. You will backfill all your headers and blocks to that state, and then you will execute forward and bring your client state to the current state. And there is a little bit of complication here, that the CL head is also moving. So you also have to keep track that, okay, the new CL heads and there are new blocks being added on the top while you are all doing all this. And then there is also a possibility of a reorg, that a CL client can signal to you again through the same engine API. So you have to take care of all these facts. But once you take care of all this, it's basically relatively simple, that, okay, CL tells you where the head is, you backfill, and then you execute all these blocks and bring your state up to the mark where CL says the head should be. And then you can move in lockstep with the CL from that point onwards. So coming to the challenges that we have for mainnet syncing. So right now, what the way you would want to be you want your client to sync on any of the network is that, okay, you will start filling from Genesis, and you will start executing the blocks, and then you will come to the head, and you will have all the state that you need. Or you can basically ask for a snapshot of the state from another peer or from a group of peers, and then you can start constructing that state onto your system. For consensus client, the state is of the order of 100 to 150 MBs right now for the mainnet beacon chain. But for uh, execution layer, the state runs into hundreds of GBs, right? So it is itself is quite big, and if you look at the history, it's that is huge. And even if you use the mainstream clients to run all the blocks without using SnapSync, it will take weeks for you to sync if you have a very good hardware. So SnapSync is basically, it offers you to download a snapshot of the state the Ethereum virtual machine is in, and basically build your own state locally using account range, storage range, bytecodes. So these are the methods that are available. And then there is further complication that the snapshot that you are building the state from, it's not really static. It's also moving, because the clients are getting new blocks and they also have to recycle their snapshots. So then there is a process of state heal that you will have to sort of rebuild some of your state MPT nodes, try nodes, so that your state is up to the mark. So this is the work in progress. This is what we are focusing upon, and this is one of the biggest thing that will enable us to sync mainnet, apart from the fact that we are also trying to be performant on our EVM. So the CL client, the window for a CL client is 12 seconds for a slot, right? So CL clients expect an EL client to execute a block in about 2 to 3 seconds, and that is a sort of a challenge for us right now. So we have to have the two prong effort going in this direction. One, to basically enable us to uh, sync the head, and then to make our EVM performant. And for that, we have done tons of refactoring recently, and some more refactoring is in the pipes to make our EVM VM really performant. We are thinking of basically running parts of our EVM through native code, through WASM code, so that we can move out of the limitations of the JavaScript virtual machine, and be really performant over there. So what we are trying to build using Ethereum JS is a decentralized backbone for the ecosystem, and to make sure that uh, we can enable light clients. We can enable things like Portal Network, apart from enabling our developers run merge ready to done our developers develop and uh, execute merge ready transactions as well as merge ready code. So this is what we are trying to make sure that uh, we provide them with something that really works, and something that they can really rely on. And thank you for listening to us. And you can clone our repo from the GitHub, and you can do code contributions. The team is really helpful and welcoming. So you are most welcome to figure things out. We have a lot of issues, open issues that are there, and you can come and you can contribute. And it's JavaScript, so JavaScript, TypeScript. So I mean, the developer base is huge. All right, thank you. Thanks.
Cool, informative, and neat presentation. I really like the term decentralized backbone for Ethereum ecosystem. Thank you for the presentation.
Yep. Very happy to be here, Pooja.
You have covered the basics, probably a few top-up questions that we have collected from the community. Um, so yeah, we will move on with what's left, or we could get a bit more explanation on. In the presentation, you mentioned Ethereum JS as a fully functional experimental client. We know it even participated in the merge devnet testing, and merge devnet testing is something where some of the mainstream clients even missed participating for a few initial days. My question to you will be, why do you call it an experimental client? What is needed for Ethereum JS to be a mainstream client for node running purposes?
Right. So the reason we are terming it as experimental is that, I mean, we would basically like to do more testing around it, build more test cases around it, around our client, how it behaves in various conditions when, you don't really expect that things are working in your way. So basically the failure cases. But most of the times our client has shown that it works. And for us to be really, to come out and say that, okay, use us, we need our EVM to be a little bit more performant, because we have 2 to 3 seconds window to run a full mainnet block. And second thing is that we have to basically make sure that we are able to snap sync and basically not require people to run all the blocks since Genesis all the way till ahead. So that these are the two major challenges that we have and we are trying to solve. So once I think we overcome them, we uh, make good progress on them, we can definitely say that, okay, we can recommend that people can use us as a client to sync mainnet as well.
That's awesome. I really hope that these are overcome soon. And from testing and developers suit, Ethereum JS become one of the node option for people running Ethereum client node for execution there.
Yep. Thank you.
My next question is about the features. One of the key features that was mentioned in Load Star, the CL client, and in this Ethereum JS as well, that is the availability of the browser environment. Would you like to talk about the advantages of browser environment and maybe invite possible users for Ethereum JS?
Yeah. So basically, typically what would happen right now is that you have some client code that will call a JSON RPC API of some gateway provider, or if you are, for example, running your own Ethereum node, basically of your home server, or right. So it has to have good capability in terms of the hard drive as well as the computing resources, right? So what really is important is that, in this scenario, what really happens is that people then trust a particular provider, and then it becomes the network basically is very easy to censor. And how to make sure that, you know y- so most of the people are concerned with a particular slice of the state. For example, they are concerned about the addresses, or they are concerned about running a particular contract, right? So they are not really concerned about the entire Ethereum state that is out there. So how can you enable them to basically take a slice of the state and run it in your own client or in your own browser, and be assured that the data that you are getting is all up to the mark, right? So uh, all that is possible right now through various APIs as well. But uh, I mean, running something for a slice, that is the thing that we are going for, to run your contract or to read the contract uh, in on a particular state slice. So that is something that in browser or light clients will enable. For example, you have your own Ethereum address, and all you are worried about is the tokens that you have on your address, right? or you want to send or exchange the tokens. Now, for that, what we want is that you should really source the state from a provider like Portal Network, and you can source the slice state for yourself, and then basically you can run the contract code itself in the browser and then submit the transactions. So this is something I think will really enable decentralization, and so it will decentralize the trust, right? So this is, I think, what I also discussed in the Ultralight client, and this is what we are going for. In Ultralight client, we demonstrated using Ethereum JS libraries, how you can basically fetch contract balances, not only Ethereum balances. So that is for an ERC20 contract, where you know the mapping of how of the storage slots with your addresses. But for any generic contract that you can run on EVM, because EVM is a Turing complete machine, right? So any contract that you can run on EVM, we want you to provide you the ability to do that in your client or in your browser.
That is awesome. I really hope the game and other app developers find it very useful. All right, moving ahead to the topic of merge. I'm aware the participation of Ethereum JS in the devnet, but I do not recall the mention of client release in EF blog post. Though I understand there was a decision to skip certain upgrades, but I am assuming we are moving ahead with merge. And that's why we have a merge ready release. What could be the reason that we do not have these releases added to the public announcement by EF blog posts? Like, were we not ready, or we just don't want to signal that we are also participating?
So I mean, the reason is that we consider ourselves experimental, and I mean, we do not want to raise the hope of our users that they can run mainnet on it, because there's still work that needs to be done. But apart from that, our Twitter releases of Ethereum JS do mention that we are, for example, Cipollio ready, and now as we added Go early, we are Go early ready. But now to sync Go early and run it in a post-merge state, one would basically really needs to let our client run for weeks, for example, right? So I mean, we want to overcome these challenges before we want to signal to the wider community that, okay, you can take us seriously. But in terms of the ecosystem, in terms of our libraries, we are definitely there, and we definitely can stake the claim to our users of our libraries that you can use them without worrying, because they do their job well, right? We are merge ready in that sense, but as a client, there are few still more challenges to conquer.
So just to summarize, like Ethereum JS is ready, just not ready for public node runners.
Correct. So our audience has been developers, and that is still going to be our focus. Uh, so our entire merge effort is to make sure that our entire infrastructure is totally up to date, and any developer can basically use that and develop something that really that can reliably work on mainnet as well.
Sweet. So we did talk about a couple of challenges. I would be curious to learn about challenges during the merge devnet phase, if there was any. I heard that Ethereum JS was doing good and was being compatible with Lodestar. It was a very good client combination for like testing the merge. Yeah, if you would like to share something on that.
Yep. So I mean, Lodestar is sort of our favorite client to drive Ethereum JS. I mean, just because it's from the JS TypeScript land, and it's like going full stack. Uh, so we did have our share of challenges. We didn't have beacon sync for a while, and so basically, if you would you would want to run Ethereum JS, you would have to sort of make sure that okay, Ethereum JS is synced up to the to the merge point, and then CL client is synced up to the merge point, and then make sure that they move from there in lockstep, right? So developing a beacon sync or optimistic sync was one of the big challenges that we overcame. And there have been other challenges. For example, that is sort of uh, we encountered, we ran when we tried to ran all the blocks, and we tried to run more post merge blocks and post merge blocks. We came across few of the bugs that were there in our VM or EVM code, or so that is something that the entire effort helped us made sure that our VM and EVM are really working well, and they are bug free, and they can execute all kind of contract code that is out there.
That's awesome. So let's talk a little bit about the future of Ethereum JS. Maybe after the merge, you did mention about the plans for network upgrade post-merge. We recently learned about the Sepolia testnet undergoing the post-merge upgrade to introduce 2124 EIP, I believe, for a specifying number of block number that nodes can use to identify peers who have gone through merge and not. Is Ethereum JS participating in that?
Yeah, our Sepolia releases have already included that hard fork, and so we will at that particular block number will fork off from the clients that have not merged, and people can use us to continue on the merged client. So basically that's what that hard fork does. It changes the fork hash so that the clients are split. So the network is split, the merged network is split from the non-merged one. And yes, our releases have that hard fork, and one should be able to stay onto the merged hard fork using Ethereum JS on Sepolia.
That's awesome. That's good to know. And I'm hoping that here on all the hard forks or network upgrades that will be added to Ethereum JS.
Yeah. So with regard to our audience, we definitely make sure that we are supporting all the hard forks, we are supporting all the EIPs that are there, because I mean, uh, for the developers and IDs that are using us, we are the go-to uh, library provider that is out there. And so our transaction library is really popular, and some of the big players, some of the IDs and test suites are using our EVM and VM. So definitely all the future goodness of Ethereum will be rolled onto Ethereum JS libraries.
Nice. All right. My next question is related to licensing. I totally understand if you would like to skip this question because it's not directly related to client development, yet people are sometimes curious to know why it is the way it is. Why is MPL 2.0 licensed instead of GNU GPL, which is like a preferred license for all open source client?
Yeah, I'm so basically I think my theory is that we want people to basically build their proprietary code using our libraries. If you use new licenses, basically you will have to open source your entire code base. But with our current licensing MPL licenses, you can build your own proprietary code, because we want uh, the ecosystem. We want all these wallet providers, NFT projects, IDE projects, right? Test suites. We want all these guys to have to build their own proprietary code using our infrastructure without worrying about having to open source their code. So the important part of running and executing Ethereum, that is open source, and we just want to enable how they want to integrate with the Ethereum ecosystem using our libraries. And our current licensing is what allows them to do that.
That makes sense. We ultimately need a product to be used. Licensing is something that should totally be on team to decide for. Thank you for sharing this.
Yep.
For community, what would be the best place to follow the resources and how they can contribute if someone is interested?
So if someone is interested, they can hop on to our GitHub, or they can come to our Discord, right? Our entire code base is open source, and you can come over there. You can look at the code base, you can look at the issues that are there, and if you want to contribute, you can contribute. We already have a very good number of contributors which have contributed to the code base. And you can also come to Ethereum JS Discord, right? Ethereum JS has its own Discord, and you can come over there, you can say hi, and you are welcome to discuss things, you're welcome to ask for things. And if you want to contribute, you're always welcome, right? Because we love contributions from our community members.
Absolutely. Open source project always invite community contributions. So whoever and whatever way they could contribute, they are always welcome. Well, it's time to wrap up. Anything else that you would like to share with the community related to the client development, the merge upgrade, or anything in general?
Yep, just stay in touch with the work that we are doing, and definitely, we'll at some point we'll be able to sync mainnet. That is what we are currently aspiring to do, and definitely we want Ethereum JS to be used in a big way in all the light client ecosystem that is building out there.
Sweet. Gajinder Singh, we appreciate you taking out time to talk about Ethereum JavaScript, an execution layer client that could be a node running option for Ethereum users very soon. Right now, it is only available for people interested in experimenting. It's not fully ready for mainnet node running. I really want to see the adoption for Ethereum JS and it to be a part of real client diversity to own network share of Ethereum after the merge. With the information shared today, I am looking forward to see more people joining in to run Ethereum node and also to do the experiment as much as possible. On this note, thanks to our channel subscriber for watching and listening to this special episode on Know Your Client series. Check out descriptions for related links. Hit like and share to increase the reach. Should you have any question on this or any other EIP, let us know at EatCatHerdesDiscord. We'll be back soon with another interesting talk. Till then, keep watching or keep listening. Keep sharing your love with Ethereum Cat Herders. Cheers.